Welcome back to part 5. In the last experiment, we added real-time animation and iterated our way up from using scalar variables to arrays to hashes, and finally concluded with classes. And so we're going to continue that experiment into classes and start investigating playfields. Playfield is your canvas as the area that all these other things happen. Some people call these things widgets and others called them actors. We're going to call them playfield objects. And the big idea is that we put all the guts of managing the canvas and the keyboard and the mouse and the real-time timers into the playfield. And then the objects that go on the playfield will handle everything else, like how they behave. For example, getting drawn, moving around on the screen, bouncing off other objects, and so on. To kick it off, let's take a look at our Canvas fun. And I've really simplified the playfield. I've gone all the way back to the first exercise we did when all we're going to do is draw some boxes. The playfield is a class, and its constructor takes a canvas ID, which is the name of the canvas on your HTML page, grabs the canvas, grabs its context, and creates a empty list of objects that are going to be on this playfield. We have two methods. One is to add an object, which also updates the object with a pointer back to this playfield, because occasionally we'll need to have the object tell the playfield to do something for it. And then we push that object onto the list. And then we have the redraw function, which does what the redraw function has done in the past, which is it clears the canvas completely and then iterates across all the known objects and draws them on the page. That's our playfield. It's as simple as we can make it. Now we're going to talk about our first playfield object, which is the box. It also has a constructor. We've added a name, which is a label that appears on the screen. The color of the box, its XY location, and its width and height. And the constructor does nothing more than record those state variables and make them accessible to us. And the one and only method that we have for our first playfield object is to how to draw it. And it's very straightforward. As we did before, we fill a rectangle with whatever color we've assigned to this object. And then we draw a box around it, a black box around it. And in the middle of all of this is some text. We just put some text in the very center of this object so that we can give it a name. That's all there is to it. Now our index.html changes a little bit, pulls in the playfield, pulls in our main code. Again, I've separated out our program, if you will, from our objects, and then main.js then just creates the objects and then does a redraw. And I've also introduced a new file called utils. This is a list of functions that we'll be using. I have a log function whose big idea here is that at some point we'll just comment out the console log so that we don't see as much noise on the background. Error for error messages between, to check to see if a value is between two other values, and then random to return a random number between the minimum and the maximum. By the way, this underscore on the front of each one of these is just my naming convention. There are a bunch of functions and objects and classes inside of the browser in JavaScript, and to give ourselves a little bit of a namespace, I just put an underscore on the front, hoping that we won't have a collision with anything that already exists. And also to make it clear that it's a utility function. We'll want to include that as well. If we go back now and we look at our main program, we create 4 boxes and we add them to the playfield, and then we redraw the playfield. And that should be fairly straightforward. Let's just pull that up, open it in the default browser. And there you are. There's our 4 objects in their playfield. That's the very beginning of our playfield exercise. We'll move on to our next exercise, which is to make each of these objects selectable. They all start off with no black box, and then as we select each one, the select black box goes to each individual object. This experiment is designed to allow us to select an individual box and to show it as being the selected box. As before, we have our add and our redraw function, but now we add a new function called find object in bounds. And the purpose of this is to take an XY coordinate, presumably from the mouse, and iterate over all the objects on the screen to find out if that XY coordinate is within the bounds of one of our boxes. And down here within box, I've added the method inBounds, which will return a true or false if an XY pixel coordinate is within the bounds of our box. We've also added a couple other methods, which is select and deselect, which will turn on or off the is selected flag, the click method, so that if we click on a box, it does some action. And in this case, it's going to print the name of the object, and then our draw function as before, except that now we've guarded that black box that prints around the box. We're now going to only print it if this is the selected object. Okay, and of course the is selected flag starts out as false. We're off to a pretty good start. We did have to add in this one capability, which is the mouse down handler. The mouse down handler will take its event, grab the playfield from it, and then check to see if the mouse's XY coordinates are within the bounds of this playfield event. And then if it is, it will call the click method and then redraw the entire screen. And in addition to clicking, let's add a new method that will make this the currently selected object. We do that here, select object. And all we're going to do is call the object's select function. Okay, let's see how that works. Nice. Now red is the selected object. Oh, and it turns out that all of them turn on. We also need the ability to recognize when an object has previously been selected and now can be deselected. Let's do that. We have this selected object variable. Let's make that this dot selected object equals object. Then we can say this dot selected object equals, or excuse me, dot deselect. Now red is selected, orange is selected, but red has been deselected. And so now it works the way you'd expect it to. We have a clearly defined selected object. Now, one thing is that if I'm clicking on the backdrop, you would think that it would deselect whatever object was already selected. Let's see if we can fix that. If the object was found, click on it and then make it selected. In fact, I'm going to switch these around. I would think that if I made this the selected object, I might be interested in that when the object was clicked on. Also, if it's not, then I want to do a playfield dot deselect. Let's add that. And the assumption is that we're deselecting whatever object is currently selected. If, for example, this selected object, then this selected object dot deselect, and this dot selected object equals null. Okay. Refresh. Yes, red is selected, orange is selected, and it deselects red, blue, green, and backdrop. Very nice. Notice that when I selected the green and then clicked on the backdrop, it is no longer the selected object. We have fully satisfied our requirements for creating the selected object. Now let's move on to our next experiment. As much as fun as it is to select an object, it's even more fun to drag it. Now, in order to drag something around, you have to grab it, as we saw early on in our experiments, and then you have to move it. The first thing we need to do in order to recognize when something is grabbed is the mouse down. And when we do that, we need to compute the drag object. And then down here, in the same place where we found that object, we not only want to make it the selected object, we not only want to click on it, but we want to make it the draggable object. And otherwise, we want to drop it. Okay. And likewise, we want to drop the object when the mouse is released. And notice that different from the experiment that we did earlier, we're not sending all of the mouse events to the same mouse handler. We're now sending them to individual different ones. Okay. And notice that we don't care about the event in this case. And then finally, so I need to wire those up. We need to handle the case of when we move the mouse. When we move the mouse, first we want to see if we have a draggable object. Then we want to do something with it. And then we are telling it where to drag it to. We're going to drag it to this XY coordinate. Let's go down here. And mind you, there are other things that the object can do when it knows that it's being dragging. Imagine, for example, if instead of a box, it was a line. What we might want to be able to do is drag the tip of a line around and rubber band that line to decide how long we want it to be. In this case, though, we're just going to set the X and Y coordinates. Okay. That's actually pretty straightforward. I don't know that we need much more code than this. Let's give that a go, see how that works. Okay. Click, get selected. Ooh, it's not dragging. All right, what did I do wrong? Well, let's take a look. Mouse down. This drag object equals object. Mouse move. Okay, I want to make sure that I'm actually moving the mouse, make sure I've captured that. Yeah, you can see we have all kinds of mouse events going on here. It's not that it's not catching it. Let's check this. Oops. We'll drag this around. Okay. We're not actually dragging anything. For some reason, our drag object is not being set. When we click on this, we set this, see, right here, this. There is no this inside of our mouse event handler, and that's what's burning me. Boom there, and there. And let's refresh. Nice, still, it's working. Yeah, working, but still not quite right. And why isn't it quite right? One thing we need to do is that when we update the playfield, we need to redraw it. Let's do that. We're doing pretty well. If you remember from exercise, I think it was exercise 3, this has that sort of jumpy feeling that like I grab it and then when I start moving, it jumps to a new location. The other thing is I noticed that like when I click, it doesn't really move until I move the mouse. And so I may want to do something about that. Let's do this. Play field dot drag object dot dragging of this event. Go. There we go. And let's refresh. Nice. There we go. How did we fix this before? We kept a delta X and a delta Y, remember? We'll do this. Okay. And then when we actually grab it, we compute the delta X and the delta Y. Okay. And also, when we commence to dragging, we want to say where we want that positions to be sent. We want to send it to the offset plus playfield dot dx plus Playfield.dy. Okay. And so what happens is it offsets it a little bit. And likewise, when we go down here to do our dragging, we want to do that. And then we can try this. Oh, still not quite right. Line 48. Call it the grab object. It should be the drag object. Let's do that again. And line 62. Okay, we're getting close. I think. Yeah, that's where I moved. It's the drag dx and the drag dy. There we go. Now we're grabbing it at the correct location, and when we move it around, it moves around smoothly. We've lost the capability from, oh, I see. There's one thing that really bugs me is as I'm dragging this around, it's like falling in behind all the other objects. And if I put it in front of the green object and I click on it, it grabs the red object. And that's not natural. We really don't want that. We want that whatever object appears to be in the front is the one that we're grabbing. The reason for this is the Z order of these objects. And the Z order is how deep into the playfield this is. We added the red object first, and then the orange, and then the green. Whoops, no, we added the green, and then the orange, and then we added the blue. Okay, and so that's the reason that they're in this order. That's why the red appears to be in the back and the blue appears to be in the front. Now, when we went to pick the objects, if you remember this code here, find inbounds, we iterated from the first object that was added to the most recent object that was added in order from red to orange to green to blue. And because of that, we checked to see if the mouse pointer was within the bounds of the red object first. And so even though these other objects appear to be in the front, clicking on it picked the red object because it was the first one it came to. And one way to fix this is to just pick the last object that you find, but that would require us to check every object every time, and that can be fairly inefficient. There's a really easy way to fix this, and that is to iterate in reverse. And so what we'll do we'll start with the last object that was added, and we'll go backwards, finding the object that we're looking for. The first object, looking from the one most recently added, which would be the closest to the user, the one in the front. That's it. And so we're going to grab that one. And then we also have to say let object equal this object's sub I. And now we should have it working the way we expect it to. And there's red, orange, green, and blue. Now, if I click on green, I expect the green object to move. Yep. And orange, I expect the orange object to move. Blue, I expect the blue object to move. And red, of course. This is now working the way we expect it to, but it would be really nice if the objects jump to the front when I click on it. Let's add that. And that's going to take a little bit of what I call array surgery, where we have to cut things out of the array and then add it back in. And that is just not the most obvious code in the world. Here's the way that works. First off, we use the index of method on the array to find the object in question. And index of will return, say, 0 if it's the first element in the array, or n if it's the last one. But it will return a -1 if it's not in the list. Now, in theory, this object should always be in the list, but for some reason it doesn't. We don't want our code to break. We check to see if it's -1, return that. Now, this splice function is designed to cut pieces of an array out, and you specify which item you want to cut, Then you specify how many you want to cut, and there's an optional parameter for what you want to put back in its place. We're cutting out the one object that we are interested in, no matter where it is on the Z platform, and then we push it back onto the array, which means it becomes the last object in the list. If it's the one that is in the front, it will be pulled off because it is the last one on the list and then put back on. If it's one in the back, it's the 0th one. It'll be taken out of the 0th element. It'll become the first most recent element in the array. Let's take a look at that. Oh, the other thing we have to do, of course, we have to call that. We grab this object and then we say this, playfield dot to front of the object. Again, we've clicked on this object and we want it to become the front object. We pull it out of the array of objects and then we put it back onto the array, but we make it the last object in the list so that it is the last object drawn, which means it's the one closest to the user and it's the one that appears to be on top. Okay, there's red and green and orange and blue. And if I click red, it should pop to the front and it covers all the others. And then green and then orange. And can we get the blue one? Okay, so this brings up another point. Now, see, this is all working the way we expect. It's very natural. The blue object is the one that we're clicking on and it is moving around. But the red object has obscured everything and it would be super cool if I could send it to the back. I'm going to now write a method called toBack, which is identical in almost every way to the toFront method. And what it does is exactly the same thing. It looks for it using index of, returns if it's not there, cuts it out, and then splices it back. But this time it splices it back at the 0th index, making it the one furthest away from the user, the first in the list, and the first to be drawn, but it's the one furthest back. Now, how do we make it go to the back? We're going to make a little bit of a cheat here. If the event dot shift key, then we're going to do a playfield dot to back of the object, else make it the front object. This should work the way it did before. Okay, there's red, orange, green, blue. And if I click on red, it comes to the front. But if I hold the shift key down and click on it, it'll jump to the back. And that's a handy feature. Okay. That pretty much concludes the capability of adding dragging to our playfield. Our next experiment is going to be adding different shapes. So far we've dealt with rectangles. Now we're going to add circles and ellipses. Now what we're going to do is we're going to change this up and we're going to try and create a circle instead of a box. And to do that, what we could do, and we'll do right now, is we'll just copy everything that the box does and call it circle. It's exactly the same as a box in every way. And instead of drawing a box, we will draw an ellipse. And one of the strange things about the Canvas library is that you don't draw circles, you actually draw ellipses, but you specify that the width and the height are identical. Our draw method now says to begin a path, mark out an ellipse, and then fill it in, and then draws our text. And then down here, if it's selected, it will then also draw the same ellipse, but this time it will make it with a black stroke. We're off and running. Now, okay, here you can see we created a circle at 200, 200 with a width and a height of 50. And remember, we can draw an ellipse, so we can make a different width and height. But when you have a 50-50, that makes a nice circle. Let's go ahead and draw this. So you can see here, violet is the circle that we added. It's at the exact same location and dimensions as our blue box, and it inherits all of the capabilities of our other objects. Now that is cool. We've got a completely different object now. All we changed was the draw method, but we also duplicated a bunch of code. And that's bad. As we mentioned before, we don't want to repeat ourselves. We want to have the dry principle, which means that we don't repeat yourself. And so what I'm going to do here, I'm going to create a class called PObject. which stands for Playfield object. And I don't want to call it class object, which is natural, because the object class already exists in JavaScript and we would cause all kinds of problems. Now what I'm going to do is I'm going to grab all this stuff from the box. I'm going to drop it into the P object and accept the draw method. This is just a reminder to myself. This takes up everything that the box did, except the draw method. Likewise for the circle. Okay, and then we're going to do something called extension, right? So we're going to extend the P object, the Playfield object. Okay. And what does this do? This says, I want the box to do everything that the Playfield object does, except for anything that I change in here. Okay. And if you look at this, so all of this capability that we had before, this is basically a template now. This P object is a template of all Playfield objects. And the only thing that's different between this object and any other Playfield object is how it's drawn. Okay. We look at the box's draw method. It creates a rectangle that is filled. And then if it's selected, it surrounds it with a black border. Likewise, the circle extends the P object, and the only thing it does differently is that it draws an ellipse and then draws an ellipse around it as well. One last thing, every class, regardless of what it does, must have a constructor, and you must call the parent constructor at some point. We're going to use the exact same variable parameters, and then we say super of those parameters. Super means call the constructor of my parent, in this case, the Playfield object. And the constructor is the code that's called when you do a new on an object, when you create the new instance of that object. What we've done here, now, we've really simplified our program. We've got these Playfield objects, and they do these things. You can select and deselect. You can check to see if a point is in the bounds. You can click on it, and you can drag it. You can also draw it. The plain brown wrapper vanilla Playfield object doesn't do anything when you draw. A box extends the Playfield object, does everything a Playfield object does, except we have a special draw method for each. Now, what this means is we can simply extend to any other type of object, in this case it's a circle, just by naming it as an extension of the Playfield object. And the only thing that we have to do to update it is change the way that we draw it. Let's see if that still works. And in fact, it does. And I noticed that we have a lot of these, a lot of this noise here in our console. And the reason why I broke out the log method as a separate function, I can comment that out, rerun it, and now it's quiet. That's the reason why we have a utility for our logger. Okay, and just like before, see it's in front, now red's in front, hold down the shift key and click, red's in the back. This is working very well. Now that we have created other shapes for our Playfield, let's go back and add keystrokes because we missed that. I'm going to add some capability so that we can move our objects around, and only the object that has been selected will get keystrokes. Now we want to add keystrokes. There's a slight bit of goofiness that we have to do. We're getting the keystrokes from the entire document, which is a keystroke that appears anywhere on the web page, and that is attached to the body. What I've done is I've grabbed the body and I've added our Playfield to that so that when we call our event listener for any key down event, that we can access the Playfield, similar to what we did here with the canvas. Now I'm going to go get the key down event handler, and I'm going to add that in. There we go. And every time a key is pressed, we get the Playfield. If it's not there, we throw there's an error. And if we have a selected object, then we call key down on that object. Okay. For now, I'm just going to create a key down method. Okay. This is very straightforward. Let's see if that works. I'm going to hit a key. If nothing happens when I hit these keys, I'm going to click on red. It's the selected object. Oh, still not happening. What did I miss? Oh, I know I forgot. I turned off my logging. There we go. And I click on red, I type away, and you can see that my keys are showing up. So fantastic. That much is working. Let's actually do something useful within those key presses. Let's go back and grab the code that we used last time and back in experiment number 2, where we moved all of our objects around whenever we hit a key press. Okay. And if you remember, if the key is the arrow up key, then we decrement Y by 10. If it's the down key, we increment it by 10, the left key, and if it's the right key. Let's refresh. Now come over here. Nothing's happening. I grab my red and I'm hitting the up arrow and the down arrow, the left and the right. And it doesn't work just for red, it works for any of the objects. Okay. And we haven't lost our ability to drag things around. We just added the ability to control those objects with key presses. Okay, so that was very quick and easy. Let's do one more thing, and that is animation. As much as we like moving things around on the screen, we really like when the things move on their own. Welcome back. To add animation, we need to add a timer. And we did this in experiment number 4, where we had real-time animation. And what I'm going to do here is I'm going to get the selected object, and I'm just going to call the dragging method. I'm going to add X to it. Okay. And then we'll redraw it every time. There's not a lot to see here, but like this, what this is doing is that as soon as I select an object, it's going to start scooting to the right. Okay. And let's talk a little bit about how this works. If you look back at our main program, we create our 5 objects, we add them to the playfield, and then we draw, and we're off and running. But now what we want is we want some animation. We will call the start method, which first redraws the entire page, probably for the first time. Then it'll set an interval timer for 125 milliseconds. In fact, I'd like this to start off at, say, 250 milliseconds. And what this does is it allows us to start with no parameters. But if we specify a value, then it will go here in the ticks value. But if we don't specify a value, it defaults to 250. We'll call start. It'll redraw the screen. It'll set our interval to call this timer with every 250 milliseconds, and it'll pass this parameter, which is our playfield. Every quarter second, it's going to call this code. Okay, let's see how that does. So far, so good. If I click red now, everything's working. Oh, you know what I forgot? I forgot to start the timer. Let's go back here, and instead of redraw, I'm just going to call start. Okay, let's try again. Click on red, and now it starts to move to the right, all on its own. Green's now doing this. Every time I select an object, it comes to life. Now, that's not really terribly interesting. But what might be more interesting is if they had their own directions that they traveled in, each in a different direction. Okay. All right. Those are just some random numbers for the deltas that we're going to move these. Now, you notice that there are no delta values here. The playfield object doesn't know how to respond. We'll add these. And we're going to update our box. our circle. Where am I going with all this? What we're doing is we're setting up an environment where um, the playfield objects can move themselves. And I've created a uh, framework for this. And what I'm going to do is I'm going to add a method to all of the playfield objects called go. And now all that go does is it says, whatever you do, however you operate, it's now your turn to do your thing. And in this case, for each of them, I'm just going to increment their X and Y values by the DX or the DY. Okay. Every time we get into this timer, I'm going to say for object of object.go. And that means that every time this timer kicks off, every time we get a tick, it's going to go up here, tell each of the objects to go, and then redraw the entire playfield. And when it tells each object to go, based on the playfield object class, it's going to change its X and Y position based on DX and DY. Okay, let's give that a try. Oops, something's not right. And that's 90. Right, I forgot to use this. There we go. There we go. The timer should be playfield. There we go. And now the objects are all moving on their own. I mean, what's interesting here is look how fast the blue object seems to be moving and how slowly the orange object seems to be moving. Now, this is a trick of animation, which is that when your delta X or delta Y are small, the object moves only a few pixels at a time. But when it's large, it moves more pixels and it appears to move faster. So that blue object seems to really be racing across the screen. Well, really all that's happening is that every time it moves twice as many pixels as the others. Okay, now let's go back and fix a couple things. Now, one thing I don't like is that when the objects get to the edge of the screen, they keep going. It'd be really nice if they would bounce around. What I'm going to do now in this go method is I'm going to say that if this dot x is less than 0, I want this dot dx to be the opposite, this dot dx. I want it to start going in the other direction. Okay, and I'm going to do the same thing for the y's. If this dot y is less than 0, then the next time around, I want to start going in the other direction. Okay, let's take a look and see how that works. Here comes blue. Oh, it's bounced back. And violet bounced back, green bounced off the top, and violet bounced off the top. Very nice. Another thing I'm noticing that it's not bouncing on the right-hand side, so let's add code for that. If the X value is greater than this playfield canvas dot width, I want it to bounce the other direction. And if the Y value is greater than this playfield canvas dot height, then I want it to bounce in the other direction. Cool. Let's take a look at that. There goes blue, and he's bouncing back. Red, oh my gosh, he disappeared. What? He bounced back. That's annoying, right? We don't really like our objects to appear to leave the playfield. We'd very much like them to stay on screen. Red especially is bouncing terribly. What we need to do is to make sure that the width is taken into account. If the X plus its width is greater than the canvas, and if the Y plus its height is greater than the canvas, then we want it to bounce. Let's do that. There goes blue, there goes red. And there is still something not quite right. It's better, but it does seem to like just go a little bit off screen before it bounces back. And why is that? Let's take a look at our code. We compute the next position and then determine that it's gone off screen, and so we need to bounce. It's too late by this point, right? The object is already off the screen. We change its direction, but we don't change its value. This could actually be 5 pixels or 10 pixels off the screen by the time it gets to bounce back. We really want it to bounce before it goes negative. What we can do instead is say we're not only going to bounce, but we're going to shore that value up to the left-hand side of the screen. Okay. And likewise here, if we've gone over the edge, not only are we going to bounce back, but we're also going to set this dot X equal to this Playfield Canvas width. Now, we can't just set it to the width. We saw what happened before we did that. It looks like it goes off the screen. We've got to come back a certain number of pixels, which is the width. Okay. And then we'll do this again down here. Okay. And now this dot Y is equal to this dot Playfield dot canvas dot height minus this dot height. Okay. Let's give this a go and see how that looks. Blue coming in, boom, red, blue, green. See how they're now snuggling up to the edge and bouncing around? Yeah, very nice. I like this, and we can still do things like we can grab red. Now, red is still trying to move around as I drag him. I want things that if they are selected, not to move. I'm going to do that. If this dot selected, turn. There we go. Now we grab red, and it's in the foreground, and it's sitting still. I can move it around. It has the focus, the selection, so I can move it up and down, left, right with the keys. Meanwhile, everybody else is still doing their thing. Now, there is one last thing that I'd like to fix, and that is I would really like it if these things stopped overlapping and started bumping into each other instead, and then bounced off each other. And to do that, I'm going to need to create the concept of a collision. A collision is when two objects occupy the same space. And what we can do is just create this method called collisions, which returns an array of other objects that are bouncing into the object. We want to know what objects are overlapping this object. And so we can say for each object, let object of objects, if the object is in bounds of the object's X and the object's Y, in other words, the upper left-hand corner, if we go over here, we want to see, is this upper left-hand corner inside any other object? Is that upper right-hand corner inside any other object? Is this lower left-hand corner inside any other object? And is this lower right-hand corner inside any other object? And that's what this is saying. Is this upper left-hand corner in the bounds of an object? Is the upper right-hand corner? Is the lower right-hand corner? And then, of course, the lower right-hand corner. If any of these are in bounds, we're going to push that object onto the results list, and then we return that list. And then down here, while we're bouncing around, what we can say is if this playfield has collisions against this object, and it's always going to return an array, so we can get its length. If it returns anything other than 0 objects, then we're just going to bounce this object around. This dot X equals, let's make it random. We're going to say it's equal to random from -10 to 10. In other words, we just want this to bounce in some other direction. Random of -10, comma 10. Okay. And we'll let it go ahead and do its computation. Now we've got a complete demo of how to create objects that bounce around. and bounce off each other. And another thing, if we want this playfield animation to go faster, we can just specify that we only want to go, say, one tick, 1 silly millisecond between each iteration, and they will just go crazy. Okay, that completes our animation demo. The next step is for us to actually create games. So we're going to do a Pong game, and we're going to do tic-tac-toe, and that will complete the series. Thanks very much for your attention. I'll see you next time.